Hey, what's going on, guys? Kenzie here. You probably noticed that I'm making this chess programming blog videos every time I stuck and out of new ideas for this chess programming channel. But today's video would probably be some sort of an exception because I'm happy to announce that even though I was stuck for the previous kind of couple of weeks, now I finally managed to find a new amazing topic regarding what in particular am I supposed to be doing next on this channel. So in order to make sure that you're not gonna miss this sort of stuff, if you're interested, obviously, you just make sure to watch the entire video. Well, actually, just a little spoiler. I would be talking about the new big project that I'm gonna be maintaining on this chess programming channel at the very end of this video. So feel free to skip to the end of this video to make sure that you just have an idea like what the project is gonna be all about. But the entire video would be serving the purpose of actually demonstrating on how in particular I came up with that sort of an idea. So if you're interested, you just make sure to watch the entire video. And regarding the video itself, well, because obviously I understand that most people kind of don't really care about whether I'm stuck or not, what am I doing, and so on. And most of you has been attracted by the title of this video. So in this video, we're gonna be answering two questions. So the first one is actually, why do people write chess engines? And the other question is, why do people consider various programming languages while creating a chess engine? And apart from this very first entry here, I would be demonstrating the specific engine that represents every of these entries, just to give you a visual idea, like how the code looks like, what were the project goals, and things like that. So without further ado, let's actually start. So the most common probably the most common reason to write a chess engine is to learn programming in general. So I need to say from my own side that from my own perspective that without chess programming I wouldn't ever become a freelancer. So that was my initial passion. I just really wanted to make a chess engine. I didn't really want to code. The very first thing I did, I've opened the source code from Stockfish and tried to read that without having any programming skills at all, basically. I know this sounds weird, but that's actually what was there back in those days. And then I realized that, okay, I can't write a chess engine without programming skills, so I probably need to learn how to code. So I decided to actually start learning how to code, and that's how my initial hobby actually turned into a freelancing business. Even though my current freelancing business is not related to chess programming, unfortunately, but I'm making my best to actually make it like so. And again, like the project I'm gonna be announcing at the very end of this video actually serves the purpose of turning my chess programming skills into a career directly. So for those of you who is interested, make sure not to miss that. But anyway, it's really nice and good idea to actually kickstart with learning to code by creating a chess engine. That's the exact thing that I was doing. And why this is so good, because all the programming basics you might have encountered, like data structures, data types, loops, conditionals, function calls, and so on. So all the basics you might have encountered within the programming, they all are applied in the chess engine, and that's the great opportunity to learn on the real deal, like how the things works. Because for me personally, it would be too boring to, I don't know, like implement some algorithms abstractly without creating something in particular that is interesting to me and make kind of sense to me. And I have a friend who's a really good programmer, and once I asked him, how do you consider, is there anything better than a chess engine to kickstart learning programming in general? He said, like, yeah, probably there is no better project than chess engine to kickstart with if you really want to learn how to code. So For those of you who has no idea how to code and want to just jump into it but don't have any projects in mind, like where to start, and you're bored with this traditional approach, welcome to chess programming, because that's absolutely exciting thing to consider if you really want to learn how to code regardless of programming language. So that's kind of the very first thing. And I'm not regarding this entry, I'm not showing the corresponding chess engine on GitHub, because you just go to GitHub and Google and search for something like beginner's chess engine to learn how to code, and there would be really lots of chess engines that were people just trying to write a chess engine just as a proof of concept to make sure that their programming skills has been gained or improved or something. So that's really lots of examples there. Not all of them even are finished, but that doesn't matter, because the project goal was just to learn how to code, just to try these skills, things like that. So the second reason why people writing a chess engine is what I call to assert their principles in programming, and this is already an interesting topic to consider. So I have a corresponding engine to kind of visualize this idea. So like there are really lots of principles and paradigms I can't pronounce that, sorry. So really lots of ways of how one can proceed while writing a chess engine. So let me just close the window, and I just want to show you one of the examples which kind of asserts the programming principles and which serves probably as one of the best chess engine code ever in terms of layouts, project structure, and things like that. So there was an engine called Fruit, initially created by Fabien Letouzy, which is a French chess engine developer, which later on he disappeared for years, and then he came back with a new and strong engine called Senpai. But his Fruit is kind of something that would be forever out there, basically. And some guys has rewritten it using just altered the mode generator a little bit and just try to update it slightly a bit as well. But it doesn't matter like how in particular the updated version that is not even created by Fabien anymore. It's not the matter of how it's different. Is this somewhere in README? For development principles. Yeah, I want to say thank to Fabien for his clean code written Fruit, and Ryan for his nice supporting code work so far. So I don't remember where exactly I took that from, but the idea was that the guys who tried to create this new so-called reloaded version of Fruit, they try to follow the principles that were involved in the initial Fruit chess engine by Fabien. So if you just have a look at whatever source code, well, even though it's like in C++, still I guess it's not going to object-oriented approach, so just the plain functional paradigm. But the code is very nice, clean, and every single function has a very clear definition. So this is something that really many people were kind of learning with. So you see, like very nice, very clear variable names. So it's just taking the board structure as an argument from square to square. So it just, I don't know, like really lots of asserts here. And it's not to assert the programming style, as you might wonder, but asserts in C just serves the purpose of make sure that the program's behavior is the exact as you expect in it, so nothing wrong is going to happen. Well, in chess engine there might be millions of bugs to occur, so asserts are usually used in order to try to track those bugs at the early stages. So this is kind of the world's I don't know how to call this, the world's proved to be the cleanest and the best ever way of writing a chess engine. And if you have a look at the source code by Richard Albert, also known as Bluefever software, with his legendary series on programming chess engine in C, you will see that he follows this asserts principles, variable naming, and the overall structure of the code really a lot. So I think that actually this fruit-like code influenced the Vice Chess Engine's structure and how it's done kind of pretty significantly. And at some point that has influenced my own coding style as well. So this is what I call like to assert the principles in programming. So some sort of a particular guidelines to follow when you write in a chess engine. Well, actually, there are many paradigms, as I was trying to pronounce this word before. The idea is that many developers, well, for those guys who are already kind of experienced developers and just entering the chess programming world, they often use the programming habits to actually assert them the most while writing a chess engine, because chess engine is something perfect that where you can make sure to assert your kind of principles and paradigms you're working within. So that's kind of another idea. And one of the other examples of this, to show this, there is a nice engine in Rust programming language, which I would be referencing later on in terms of considering different programming languages. But also this guy, Marcel Vantor, I'm not sure if I'm pronouncing his name correctly. So he's a big fan of Rust programming language, and he also an embedded engineer. So he uses some fancy embedded software like principles when he writing his engine in terms of communication of the different modules of the engines of the engine. Well, that part is kind of too, that stuff is kind of too complicated for me, and Marcel is much smarter than I, so I'll just quickly run through the source code later on when it comes to Rust. But at the moment, just want to give you an idea that this engine, Rust by Marcel Vantor, might serve might also be not only in terms of example of a Rust programming language, but also another example of how to assert their principles in programming. So that's why I can conclude when I said the source code of the engine. And by the way, all the links to all the engines that I'm showing you here in this video will be available in the description below this video. Another very big kind of like a very huge reason to write a chess engine, which really I think this is the category with like it has the biggest number of followers basically. Not many succeed in this, but really lots of guys has really big ambitions to satisfy. So they're trying to create a top engine so to compete with Stockfish one day, with Komodo, with Leela. Really, not really that many people actually ever succeeds in that. But this ambition-driven stuff is today's world's evil basically, and that is something that we can see in Talk Chess, unfortunately, where everyone is trying to make this damn strong engine and like try to sacrifice anything, but just like I heard a joke once, so something like to have a divorce with his wife just in order to gain another 100 elo to his engine. So something like that. I might be wrong in the details, but the idea is like almost like sell your soul to devil just to get another 100 of elo points. So this is something that I don't really but that's something that is actually happening in the chess programming world, and this is the most this is the biggest stuff that is happening out there. So the engines that are trying to be ambitious are kind of the most number of engines actually trying to be ambitious to get into the top one day. Unfortunately for me, because I'm highly incompetitive guy, and I hate competitions really, because I strongly believe that everyone has his own dedication, and trying to compete is just a waste of time and energy, because you could have just tried to make something useful for people and not trying to satisfy your ambitions, which is totally pointless in my personal opinion. But anyway, I want to demonstrate a one of the examples. So there is the most ambitious guy called Andy Grant, and his engine Ethereal, which is now Andy has created his own efficiently updatable neural networks, which are different from Stockfish, but he's so smart that that he wants just to close that and never kind of. So he tries. He hates when people like me actually copy paste in efficiently updatable neural networks from Stockfish, and he wants to prevent this sort of a scenario in future. So that's the reason why he probably won't be ever opening his efficiently updatable neural networks. And I had several conversations with him on JSChess, and all I heard from him, even though he's a fantastic programmer, he's very talented, he's just awesome. But the problem with him is that everything. The only reason why he's doing this, well, his code is very clean. I love his code basically. But the problem with this guy is that the only reason he's doing this for is just the competition. He wants to beat Stockfish one day. He wants to be the best. If he doesn't beat Stockfish and Lil, at least he would be like the third engine in the world. The author of the world's third engine, something like that, and he's proud to be the only developer of his engine. Well, actually, it's really not so anymore, because already there are just some guys helping him around. But anyway, I'm not judging Andy. I'm just complaining that he's so smart that I can't really make any use of his work at all. Once I was trying to read his PDF file on tuning the handcrafted evaluation, and just opened that file. I saw some sort of math formulas, and I just like make this facepalm, and then I just said like, oh my god, no, I'm not gonna be. That's too complicated. I just call it the PDF file, and that's kind of it. So, unfortunately, the downside of this, amazing developers, really smart guys like Andy, that they're so smart that average dumbs like me can't actually make any use of their work at all, unfortunately. And I even saw some posts on JSChess forum where some other guys were complaining that what he does and what he explains and how he explains is kind of too complicated to understand and to make use of. So, but his ambitions are satisfied. So that's another reason like why people are writing a chess engine, just try to be the best out there. Okay, so the next one is to make complex simple and the didactic purposes, and there are really lots of engines being created for didactic purposes like TCP, Vice. Bruce Moreland was creating didactic engines. Unfortunately, I don't remember those names, and that was my goal for until now, basically. So I've created a BBC chess engine, which is which serves exactly the didactic purposes to make it easy. So I created 95 video tutorial series on how to create a bitboard chess engine in C, and I have embedded the Stockfish efficiently updatable neural networks to it. So with this neural networks, the rating of BBC engine is 2937, but without this, the strongest version was 2096. So it's kind of more than 700 elo points for this Stockfish NNE, which is incredibly powerful in evaluation by itself. And I can say a bit more about my own engine. So let's have a look at the latest version we have here. So apart from Stockfish's evaluation function, BBC is a single file chess engine, and I've tried to command every single line of code possible out there to make it absolutely clear, like of what's going on in the source code. I've tried to use the most simple C programming language techniques. I was using global variables all along the way, which I was heavily criticized for. But again, like that's the sacrifice to make it more clear on how it works in particular. And actually, I just scrolling down through the source code. I've been reusing some functions from Vice Chess Engine just to make the interaction between the GUI and the chess engine in terms of timing, like for USAC protocol, and also to read from keyboard input when we want to stop the engine from calculating and get back immediately. I use the code from Wise by Bluefever software, which should be written here. Yeah, when you're in search. Yeah, first Richard Albert, also known as Bluefever software, grabbed it from somewhere. Well, actually, not from somewhere. He grabbed this from Ollie Think, if I'm not mistaken. And oh my god, I forgot the name of the Ollie Think. Oliver Brosh. Yeah, I might be wrong in pronouncing the name. I'm sure that his name is Oliver. Was the author of this initial idea to use the keyboard buffer to read from in order to drop the chess engine from calculating without using threads, which is very, very nice and good idea to my personal opinion. Okay, and then it comes to, well, starting from the random number generator. So here I just grabbed the XOR32 algorithm from Wikipedia and implemented it. Then actually all the code here is almost all the code I've taken from somewhere, but the idea is not just grabbing someone else's code, but the idea is just to I was writing every single line of code in the videos during the 95 video series on programming Bitboard Chess Engine in C. So I kind of worked that out and tried to explain every single line of code how it works. I still don't consider it to be my own, but still it's serving the purpose of clarity, and it's made for didactic purposes basically. So feel free to watch my Bitboard Chess Engine in C series here on Chess Programming channel. If you want to get the very complicated chess programming topics involved within the modern chess engines, if you want to get them in a really easiest possible way, this BBC Chess Engine is something for you. So you can see that every single line of code being commented, well, almost every single line of code, but still, I've never seen more commentaries in whatever chess engine compared to this one. Every time when it comes to a need to describe of how some variables like these constants work, provide some mappings, binary mappings to give you an idea of like what the constants are all about, how they work, and so on. So here we have the code to generate the magic numbers. These are the magic numbers themselves. The magic numbers is the number to multiply occupancy by in order to obtain index within the magic bit words paradigm, which is de facto standard for modern chess engines, for modern Bitboard chess engines nowadays. Also, we have this pre-calculated attack tables to speed up the move generator. Yeah, so this is all about the move generator. Not even the move generator yet, but the pre-calculated attack tables. And here is the piece of code that I've reworked a little bit from Chess Programming Wikipedia. And initially, this code was written by Tom Romstead, the author of Stockfish Chess Engine, but it was so obfuscated to me personally, so complicated with not really meaningful variable names. So I reworked this significantly, simplified as much as I could, trying to command every single line of code available to make this sort of stuff being clear for average developers like me, trying to understand how it works. And then it goes to the move generator. With this pre-calculated attack tables, things like square attack functions is really trivial here. Some helper functions like the print the attack square. Then it comes to moving code into a single integer, an idea taken from Wise by Bluefever software, and so on. So it's kind of puzzle from many sources, but it has this source code has kind of like the single thread that combines everything, gathers everything within the single idea of making code as clear, as simple as possible to make as many people as possible trying to understand on how it works. So I hope that's clear. So this is what I call to make complex simple and the didactic purposes, and that's why I wrote that BBC Chess Engine. And if you have a look at, say, the code of TSCP, even though it's simpler, it feels like a lack of commentaries there, so it's not really that easy to understand how it works. I started to understand how TSCP works only after I don't know, only not very long time ago, basically. And regarding Vice, again, like you can understand how the Vice by Bluefever software works only if you follow the series. But if you just take a source code, if you're a noob, you won't get anything from there. But if you're a noob and you take BBC Chess Engine's source code, you most likely would understand what's going on. Well, at least I hope so. That was my initial kind of goal. And another, the last reason to create a chess engine. Well, maybe it's not correct to call it like to try new ideas or for fun. Maybe it's not really the most accurate way of calling this, but I just want to show you. So here is one of the smallest chess engines in the world, called Micromax by Harm-Gerd Müller, the legendary chess programmer. This is the entire source code of his smallest chess engine in the world. So like it's really obfuscated, and I made a couple of tutorials on deobfuscating this sort of stuff based on his tutorial that is available here on his site. So very interesting minimalist design and architecture for a chess engine. It's not, again, like it's not intended for speed or strength, even though it's quite pretty strong. If I'm not mistaken, it even beats DSCP, which means that it's probably stronger than 1700s. Well, I'm not sure. I just need to check out the CCRL LO rating for this engine, but it's quite pretty. It's quite pretty strong for its really little size. And then Harm-Gerd Müller created this more extended version that already makes use of transposition table, believe it or not, things like various search optimizations like futility pruning. I'm not sure, probably null move pruning as well. And well, just need to recall this in my memory, don't remember really. But anyway, so this is something unique that no one else but Harm-Gerd Müller actually does. And I spent really a lot of time researching his work and trying to make it more simple. And like you can have a look at I don't remember how they're called, one of my recent videos on bare minimum chess engine in JavaScript with user interface. So I've used the ideas from Harm-Gerd Müller and the GUI ideas from another minimalist engine called NanoChess, authored by Oscar Toledo. So this is another one of possible ways why people write in chess engines. So why this source code is so important is that because it has a brilliant architecture. Like we have the 3 nested loops within the move generator. Just to give you an idea, like the difference. So let's say have a look. Let's take my engine, right? Let's take generate move function. Just want to show you this. Just let me find the generate moves function. So this is how big the generate moves function is in engine like BBC and similar. So it's quite pretty big, you see? It's really kind of quite pretty big here. It's really big. But if you have a look at the move generator from Micromax, I can just let's say, nope, not here, basic moves. This is literally the entire move generator code, believe it or not. So we have 3 nested loops, loop over the target squares where the pieces of the specific color occur in, then looping over the directions where pieces can go, and then we need to go within every single direction. We need to go for squares within the array, like for sliding pieces, and for leaper pieces, which is faking the capture. Well, this is very interesting stuff. Again, like just check out my bare minimum chess engine, chess engine in JavaScript with GUI, one of the recent videos, just to have an idea of how this kind of minimalist approach and architecture works. Well, okay, so we've just finished with the reasons why people actually can write in chess engines, and now a few words regarding why do people consider different programming languages. And you know, like it's quite pretty often to hear in the chess programming world, like why on earth to write a chess engine, say, in whatever other language but C or C++, because C and C++ are the fastest languages out there, And if you're writing a chess engine in somewhat a different language, that doesn't make any sense, because your engine would be weaker and slower compared the same version of your language, but written in C programming language. Well, the very first thing I would like to answer to this question is that this sort of a question is often asked, mostly asked by the people who actually trying to satisfy their ambitions. So if you're trying to satisfy your ambitions, you definitely need to consider C or C++, because this is the strongest and the fastest you'll get the strongest and the fastest engine, because C and C++ are the fastest language, because they're directly interacting with your hardware. Well, not really directly, but I hope you understand what I mean. And also with various hardware specific optimizations, like modern processors has specific instruction sets to speed up the performance in number of times, just by using a single optimization options within the make file while you're compiling your chess engine. So C and C++ is something that is intended really for speed and strength, and the world's champion among chess engines, Stockfish, which is developed by a really great team, numerous teams. So they even have somewhere they have the file called authors, and there is so many guys out there. I don't know, maybe this is just the wrong repo, or maybe this is just an old version. I'm not sure. Oh no, here it is, the authors. So just to give you an idea of how many people actually contributed to Stockfish development, you see, like, it's really fantastic number of I'm not gonna be I don't know, I could have tried to no, not this one. I could have tried to have a look at the source code, but to be honest, for me, even now, even after I've written really several chess engines, well, first of all, I don't know C++. I don't know how this object-oriented stuff is done in C++, unfortunately. So this is kind of too complicated for me. And on the other hand, it's kind of like, you know, well, even though it seems like they providing commentaries as well, but for me personally, the Stockfish's source code is kind of too complicated even now, because I don't know, maybe I wouldn't be smart enough to understand this. But anyway, the years of development and also the reason behind Stockfish's success is because it has a fantastic testing framework, and they rent in the servers with a high capacity to run all of those tests, especially when it comes to efficiently updatable neural networks, which is the cutting edge technology initially implemented in Stockfish, well, among other chess engines, which also needs processing power to train a neural net as well. So they have spent really lots of money to actually make this sort of a chess engine being that strong. So just to give you an idea, the matter of strength in chess programming, if you want to create a really strong chess engine, you can't do that without spending money on renting servers to run all of those tests and things like that. So if you want to create a really strong chess engine, you definitely need to invest your own money into this process. And this is a bit weird, but yeah, to make the strongest chess engine in the world, it also depends on how much money are you ready to invest to that sort of a project. So I hope that's kind of pretty clear. And the next thing to consider, another language is Rust. And again, like, I've never heard of Rust, basically. I just knew that the language named Rust exists there before this guy, oh my god, where is he? Marcel Van Toor actually introduced me to Rust, and I personally considered Rust chess engine to be very exciting, since he has explained me. So the idea is that, just like in C programming language, programmer is, well, I don't know Rust at all, so it's kind of rocket science to me. I'm not really sure what in particular is going on here, but the syntax is really similar to C at some point, and the core trick, kind of behind the Rust that a programmer is capable of managing the memory at the low level, just like this is done in C. So it doesn't have a garbage collector like Java has. So the matter of actually managing the memory and how exactly you do it really depends on the programmer. And like they say regarding Rust, that if you don't understand like how the memory operates, you better don't touch Rust, because otherwise you might have end up with a horrible segmentation faults and issues like that. But Marcel is actually he knows what is he doing, and that's the reason why he loves this engine so much. And Rust seems to be as fast as C. And again, like as I was mentioning before, the reason why Marcel does this, he just feels like, well, at least what he told me, he feels like it kind of like the Rust fits his programming principles that he's trying to assert, and it just, you know, like some sort of a language he pleased to write source code in, because I don't know, because it's kind of fits his programming paradigms or something. Well, sorry, maybe I'm talking a bit weird things, but that's at least how I understand them. So Rust is very interesting C-like programming language. Regarding Java, well, actually, this might be a little bit kind of discrimination, but to me personally, I can't see other reason of writing a chess engine in Java other than if you're a Java nerd, because there are just people like who just loves Java for some reason. Well, I personally hate Java with all of my heart. I tried some Android development in previous, but I didn't really like it. Well, actually, another kind of true reason to consider Java if you want to create a chess engine for an Android app. Well, obviously that's in that case Java is the case. I heard that Kotlin programming language seems like it starts being used in Android development. I'm not sure. I just heard something. I didn't research that, so don't listen to this. So yeah, considering Java to create a chess engine for an Android app might have been a good idea. And actually, there is a nice engine called Cuckoo Chess. Originally, it was created by Peter Osterland, the author of the famous Droid Fish GUI, and that's the Android app, which is the UCI compatible GUI for Android. And the Cuckoo was the engine that was within that sort of application, like built-in engine there. But again, like as far as we can link, as far as we can use the UCI protocol and run the engines on Android smartphones natively, because we have ARM compilers, I can't see much reason to create this Java version. Well, maybe just for some kids app, like if you want to learn kids to play chess, something like that. Well, but again, like for me personally, even though there are some real reasons to write chess engines in Java, like for Android apps, still, to me personally, it's the matter of being a Java nerd. And I don't disrespect Java nerds at any point, but I just want to say that Java is something that is really, that I personally don't like, and I don't understand why people love Java so much. Well, probably because my programming style is kind of opposite to the programming style that is used by Java programmers. Probably that is the reason. Будь здорова. Sorry guys, my wife is sneezing there. Okay, so Python, so probably simplest and most trendful programming language nowadays. So like it seems like the world starts getting written in Python overall. So very famous for backend web development. I know that because I was doing really lots of backend web development in Python myself as a freelancer. And also, well, despite the fact that you can just create whatever programming language in Python, and that's probably the simplest way to probably the simplest language to learn. Python probably is the simplest language to learn. Probably the simplest language to write chess engine in. But in the recent days, the reason for using Python, there is another huge reason for actually using Python while writing a chess engines, and probably most of you have heard of LilaChess Zero chess engine, which is absolutely kind of different to Stockfish in terms of how it manages the game of chess. So it's kind of it involves a really huge neural net, and in general it's kind of machine learning language. So the idea is that it doesn't use the alpha beta search, but instead it uses neural nets, and neural nets are the part of the big machine learning sphere and in programming in general. So there is a nice engine called AOLite, and his author Dietrich Kappa says, like, is this LC0, which means LilaChess 0? Definitely not. And so on. Then he just explains. So he has created the neural networks plus Monte Carlo research chess engine in only 95 lines of Python code, but it's just a matter of search, while the true core behind this engine, again, like, is the neural net, which he calls Bean Girl. He also has this Bad Girl neural net, and also the latest one is called Night Nurse, but probably it's not public, it's not available in public yet, because not this version, but somewhat a better one was participating in TSEC, which is a top chess engine competition. I just read it somewhere, I don't remember, maybe on Talk Chess Forum or something, doesn't matter. With this particular neural nets that he gives, it only plays 2050, L rated at CCRL, so it's quite pretty, not that strong, but just probably made it for demo purposes. And also he has really lots of forks, so Master actually is not the strongest one, even though it's default, but it has some fancy yeah, so this is it probably. So he has another branches that are much stronger in terms of the search optimization and things like that. And again, like, probably the actual neural network that Dietrich uses for competitions is now not available in public, because in chess programming world that's the real problem, and everybody's trying to steal someone else's network, trying to modify it a little bit and to participate in the top competitions. Again, like, that's the damn satisfaction of their ambitions, which to me personally doesn't make any sense at all. So what I can say regarding the reasons of why to write chess engine in Python nowadays, because it's incredibly easy to do machine learning, and especially deep learning in Python, because there are powerful libraries like TensorFlow from Google and PyTorch from, I don't know who has created that, but a very solid alternative to TensorFlow, which main feature is to use GPUs for all of those floating point calculations, for all those expensive calculations of floating points numbers. So nowadays, with these neural net powered chess engines like LilaChess 0 or Alpha 0, Python becomes really trendy, because the matter of a chess engine is just the matter of creating, designing, and training the neural network, and that's what Python is really fits perfectly. And when it comes to search, assuming that both TensorFlow and PyTorch has a backend in, I'm not sure in C or in C++, but doesn't matter basically. So anyway, the neural network that you've created using, say, TensorFlow, PyTorch can be later on used by a chess engine that is written in C. I mean, chess engine in terms of a move generator and Monte Carlo research algorithm. So then you can just probe the neural net that you've created for inference purposes, not for training, obviously. And you're done basically. But all the training could be done in Python because, again, like those libraries make use of GPUs for you. So that's very high-level neural network libraries like PyTorch and TensorFlow. So you can not be worried about how that works with them. But again, like neural networks is some sort of rocket science to me. I'm too dumb to get into them, and basically I dropped my attempts to get in there because, you know, like as I've been mentioning before, every guy should kind of find his own dedication, trying to serve where he can make the most use for other people. And the very last but not least is the JavaScript. So you might wonder that JavaScript is probably the slowest programming language out there, especially if you're not running this using Node.js as the server-side language, but completely in browser. But still, here we come to the announcement of for the project that I was talking about at the beginning of this video, by the way. So I just want to show you one of the chess programs. So it's created by Richard Albert, also known as a Bluefever software, and this is some sort of a port of his Vice chess engine to JavaScript, and it's a very nice implementation that I personally love so much. And so what's the benefit of using this sort of using JavaScript? Well, even though it's not that strong actually, well, still, even here it goes to the depth of 6 which is not that bad at all for JavaScript, assuming that we only have only one time, only 1 minute, only 1 second per move. One of the most benefits is that it runs completely in browser, as you can see here, so you don't need to install compilers or programming languages or whatever. You can just use the bare browser to run it. That's really exciting on its own, basically. And there are even much stronger chess engine written in JavaScript. Let's say like there is an engine called Tommy Tank, if I'm not mistaken, which is claimed to be the strongest JavaScript chess engine in the world, which is rated somewhere around 2800, which is fantastic elo rating for a chess engine written in JavaScript. Let me just try to search for that. I'm just interested. So how is that rated? So Tommy Tank, yeah, 2831 Tommy Tank chess. So we just have a look at, yeah, here is the link to GitHub. So the strongest JavaScript engine in existence, as the author claims. So it was the first full bitboard JavaScript engine in the world. Why pure? Because it's no mscripting, likely Stockfish.js. The source code is readable. Not sure what this means, but anyway, pure JavaScript 5 times slower than C language, 2.5 slower than this mscript in JavaScript. It's probably some sort of a automatic translation from C to JavaScript, not sure. Chess engine running in your browser with GUI, example arena. Yeah, so well, probably he dropped that the strongest JavaScript engine, which is not true, obviously, because probably Stockfish is stronger. But yeah, so he changed this to the first full bitboard JavaScript chess engine in the world. Yeah, so I don't know, maybe this was changed, maybe, well, it doesn't matter really. But you just saw the rating, so it was 2837, which is really impressive result for a JavaScript engine. So JavaScript engine can be quite pretty strong as well. And finally, the main reason for actually considering JavaScript, and here we already gonna switch from trying to figure out why do people consider various programming languages to the announcement of my future project. So if you have a look at sites like leechess.org or chess.com, sites like that, so you see like they use a chessboard obviously as the core feature, the core functionality of their sites. And there are also many chessboard widgets out there on GitHub, like chessboard.js probably is the most famous among them, which that's the chessboard that at least looks like the one that is used in Lichess. I'm not sure if they use that one in particular or and modified it, or maybe they've created some on their own. Not sure about that. But anyway, I've realized that like there is. Well, first let me just name the project. So I'm gonna be the next project I'm gonna be covering here in probably several YouTube series. So it would be a project on creating a smart chessboard and a smart chessboard widget. And what I mean by saying smart, so when you're trying to create a chessboard widget, you encounter a need to make it know so you need to validate the moves. That's the very first issue. Another issue might be you need to know the state of the game, like is this a draw, is this a checkmate, and so on, a stalemate, 50 rule move draw, or threefold repetition draw. So all that stuff really matters. But it's not even the most actually, in order to get that functionality, so the first approach might be just trying to create. Well, anyway, you need to create a pseudo-legal move generator. You need to create an in-check function to check whether the king is checked, to actually make sure that the moves are legal and so on. So actually, the matter of creating a smart chessboard is the matter of. So it's far easier to create a chess engine that would be answering the questions regarding what moves are legal and so on, keep track of the state of the game. And when it comes to the famous chessboard.js widget that I've been talking about just a minute ago, it's considered to be a dumb chessboard, and the author of chessboard.js actually suggests to use so-called JSChess project, which is I don't call that a chess engine, but that is some sort of a software that allows to know something about the rules of games, like making legal moves, if the game is finished, work with BGN files and so on. So really lots of functionality, and that is something that the combination of these two libraries. So when I've combined these two libraries, I came up with this sort of a user interface for my BBC chess engine that I've been covering before. So yeah, I just blundered a pawn now. It's bad. Okay, so anyway, just to give you an idea of how this chessboard.js widget looks like, and in order to make on a legal moves, so like check the move legality, to check the state of the game and things like that. So the module called chess.js is used there. But they are not the single project, they are not the same project. And also, I personally can see really lots of features that lack here. It's in example, we can't right-click on the piece and show the error and draw the error showing the plan for a given side, like Lichess offers and so on. Also, things like a window for engine infinite analysis working in the background would be a nice feature as well. So those are some of the core ideas that I have in mind now in particular. So I want to make a chessboard widget that on the one hand it would be having a full-blown kind of clickable user experience in terms of not only playing chess but also trying to mark the square, drawing arrows to show the plan, things like that. So on the other hand, as far as there would be a chess engine for move validation, it's also a good idea to use a chess engine for analysis. And one of the possible applications for this library would be to build a simple, I don't know how to call it, app or web page, or I don't know, that could be used by chess bloggers who analyzing the games in their videos. So that's one of the ideas regarding the applications of this sort of a library. But obviously, well, also I want to embed the functionality of working with a PGN file, something like they do on JSChess. So it's quite pretty similar to what they do on JSChess, but separable from the portal itself. So to give a user a single, obviously probably not a single JavaScript file library, but probably would be just a bigger project. But anyway, I'll try to make the matter of embedding this into your web page, like the matter of just simply creating, just importing the script into the document and creating some sort of an API to, I don't know, like draw a board, optionally draw an engine window, optionally drawing the buttons for make move and make move, walk through the PGN if available. Later on, probably working with the chess databases. So I really wanted something that would be extremely easy to install because JavaScript runs completely in browser. So something that could be used either by those who are analyzing games, who want to make it online, that would be available for Android devices or iOS devices as well, because that would be just a matter of literally using the web browser, no matter regardless of hardware you're running your web browser on, actually, regardless of the operating system. So it would be total cross-platform for me, because web is probably the world's most cross-platform technology out there available. So that's kind of the idea. And again, like the core gist behind this idea, and like why to use JavaScript, because it's really cross-platform, and I really want to make this library. I think that the library is just a matter of the format, because when I'm looking at the source code of my BBC Chess engine, to be honest, what it reminds me a library, believe it or not. So I really want to make the library to make it in a format of a library, and probably make a couple of projects showcasing the usage of that library. And one of those projects might be like creating this little page for those who creating chess, who creating chess videos, chess analysis videos, like analyzing the grandmaster's game when not using the chess-based interface, because that's paid and you might not have that, or whatever. If you have a different operating system like non-Windows, you might have issues with that as well. But you can just open the browser, like make it full screen, and have all the features that you want. But well, you can do this on JSChess, obviously, but I don't know. I just have some ideas in mind. Not sure how in particular it's gonna be working. But the core gist is, I realized that the chess engine itself is the matter of strength and power. And if you're just trying to make it stronger, more strong and more powerful, just to make it stronger and powerful, it starts to be the matter of satisfaction of your own ambitions, which doesn't lead anywhere. But using a chess engine to make a chessboard is kind of smart, and focusing on the chessboard widget instead of a chess engine is something that we can use to help other people every time they want to embed a chessboard into their website, or maybe use it as a single application, regardless of a website. Also, it would be incredibly easy to showcase the library and its capabilities by hosting on GitHub directly, so no need for using backend servers to host that app, so just the pure static files, which is also good. So yeah, it's kind of like you only use the power of your own computer, without a need to use the power of a remote server, so you don't need to pay for that. It would be 100% free forever, because my email, like most of you probably know, is freesoft.for.people@gmail.com. So I really believe that the software should be free, and something that we're getting paid for as programmers or as freelancers is for solving tasks for our clients. And I really hope that my library, when I make it in future, would be helping other people to solve their tasks, and the matter of embedding this sort of a library to their websites with something might be the source of the future jobs, and hopefully not only for me, but maybe for some of you guys as well. So that's kind of the plans of Code McKean, and this is it from my side. for today. I'm now starting really heavy work on designing this project I've been describing. Well, probably I will start with creating a chess engine in JavaScript. I will use one of my previous mood generators. Probably I won't be going for bitboards because it's kind of like too complicated, and I can't see really much reason for using bitboards because this engine would be kind of serving the matter of validating moves for a chessboard and maybe just analyzing some tactics or made in 3, in 4, like some forcing lines. It's not going to be intended for play, even though it would be possible to play versus the engine. But again, like the purpose is not to make it strong to play against people, but just for some analysis purposes to check the blunders, things like that. Then probably I will go for creating this chessboard widget. I really want to go from scratch. I have lots of ideas to try out there. So I think this would be interesting. Well, at very least, there would be really lots of content on this chess programming channel in the near future. Or at least I hope so. So this is it from my side, guys. I hope you've enjoyed the video. For those of you who is interested in my work, feel free to subscribe to chess programming channel. Only if you're interested. And I think that some sort of an amazing journey is awaiting for all of us. So until the next time, and take care.